We did not quite make it through all of the things. Okay. Reminder. Next week, Wednesday and Thursday, start final exams. Your final exam will be here on Wednesday, 7:30 till 9. We will talk about it next week. But basically, you need to bring what you feel you need to do the test. Okay? It's open note, it's open book. You can use whatever you bring with you. If you want to use your computer or try to, you are welcome to. Okay? Any questions that you have for me today, ask them. As you are going through the practice test today, if you need help with something, please ask. I will be more than happy to assist you in interpreting a question, rephrase it for you, or try to make it more clearly. But we do need to finish just a little bit of notes, and that is this page right here. Okay? Now, yesterday at the end of the hour, we were talking about these. By the way, this periodic table, this one here, in the spot for carbon, group 14, period 2. You should have element of life there already. I would add to that element makes a covalent network solid. Carbon makes a covalent network solid. That is what we were talking about yesterday with diamonds. The bonds in here are the strongest bonds that we know, which are covalent network solid bonds. That is what makes diamond the hardest naturally occurring substance known to man. Okay? Solid. It's a covalent network solid. Now I will put these out on the back table again. There's already a copy of them out there. Anything that you feel you did not copy or did not get off of the board, you can go up, you can look at them, you can copy it onto your periodic table, onto your sheets, whatever you would like to do. Okay? Now, the four terms that we had yet to define on your blue sheet were intra and intermolecular forces. Intramolecular forces are forces within atoms. They are bonds, covalent network solid, ionic, metallic. Those are intramolecular forces. Intermolecular forces are the force of attraction between molecules. These are much weaker than intra. Okay? Now, there are three kinds here. We're not going to worry about hydrogen bonding. Okay? It's not on your blue sheet. We're not going to worry about it. But these two are. Now, technically, this is the medium intermolecular force, which means it is not as strong as hydrogen, but it is stronger than London dispersion. But please remember, on our blue sheet, the lowest form of electromagnetic radiation, the one with the longest wavelength of all electromagnetic radiation is which one? Correct. But what's the longest of all types? Not just on the blue sheet. Radio and TV. So please understand, with these two clues on your test, even though this one is the medium force, of the ones on the test, it is the stronger of the two. Okay? Now, this is a force that is between any compound that has these lone pairs on it. These lone pairs on a compound mean that it is going to have this van der Waals forces holding it together. Which means, ladies and gentlemen, if you will take a look at the periodic table that we wrote all this stuff on yesterday. This one here. Okay? This can happen in the nitrogen family, the oxygen family, and the halogens. That is the only place that van der Waals forces can happen, because in the carbon family there are no lone pairs. In the boron family, there are no lone pairs. And in the alkaline earth metals, there are no lone pairs. Yes, Danaya. Van der Waals forces. This one here. Okay? Now, London dispersion forces occur in things like this, where there are no lone pairs. So this is the alkaline earth metals. This is the boron family. This is the carbon family. They would be bonded by what are called London dispersion forces. Also, every diatomic of the 7 diatomics, they are all London dispersion forces holding them together. Okay? Questions? Okay. So if you would, please take out test 1 real quick that I gave you the other day. And if you don't have it or you lost it, come up and grab a new one up here. You also need one of these blank periodic tables that I gave you the other day. Okay. Now, on your test, if I give you a clue like clue number 1 that says elements A, F, K, P, U, Z, Z, E, E, and J, J are all third period elements. Here's what I will tell you. I will not give you one like this on the test. Not with like, how many are there? 7 things to place there. Because it would be ridiculous for me to do that on the test. It would be like the element named after the scientist who did the law of octaves. And the element named, I wouldn't do that. But what you'll notice is in clue 1, I say that all of these things are in the third period. So my suggestion to you, ladies and gentlemen, is if you get a clue like that, either over on this side or this side of the third period, you would list them. A, F. Now, again, I won't give you all of them like this, but it is possible that you will get a clue and you will be debating between 2 spots on the periodic table. Now, if you skip the clue, it might have put an element in one of these 2 spots. Okay? But if you get, and you're like, I know it's in one of these 2 spots, put it in between. Because it's possible that the very next clue will tell you which spot it goes in by occupying the other. I do not leave you hanging on this test. In other words, if you're debating between 2 spots, either the next clue or an earlier clue that you might have skipped should have put something in there so that you can put it into place. Okay? Now, I am not saying you can't skip questions on the test. It is always a good strategy that if you don't know the answer to a question, to skip it. But what I would tell you is, number 1, circle it and make it easy for you to find. Okay? Make it easy for you to go back to. And if you know like something about it, if you know what the element is, put it next to it. So when you come back to it, it'll be a little bit quicker for you to find. Or maybe you could figure out what period it's in or what group it's in, but not the other. Again, make it as easy on yourself as you can while taking this test. In the end, 50 clues go in 50 spots. 1 spot left at the end, that's where the last clue goes. Okay? So, what I'm going to do today is I'm going to give you time to work on this. At the end of the hour, I need about 12 minutes to go over this. And I will go over this with you clue by clue. Right now, what I would tell you is, again, for this one, I'd get in a group of 2 or 3 people. I'd go back to a lab station. I'd work on it together. Talk through the questions. If you can't come to a consensus, call me over and I will help you. But the only way you're going to get better at this is to practice. Now, again, the questions on here are what you're going to be similar to seeing on the test. But it obviously will not say K is slightly reactive with water to form a base. It will say the element named after the scientist who did the law of octaves is a slightly reactive substance that forms a base with water. Questions? The period is yours, ladies and gentlemen. Please use it wisely. You bet. Okay. So, J is large. It's so, here's the important point. That's how many reasons goes down. Okay. Okay. So then you understand the improved part of the last part. It says that JJ is smaller than an ion of Yes. Correct. So even though as an atom, one is smaller, as an ion, it could be larger. And if it's larger as an ion, that's what is on the non-metal side. What is on the metal side. Because if you just look at atomic radius, it goes across, it goes down. But ionic radius goes down, then it jumps when you go to the non-metals. So if it's a bigger ionic radius, but smaller atomic radius, it's after it, but it's on the non-metal side of the yeah. Larger means it's further to the left. As an atom, larger is further to the left. So we have this is the last one. So when you get stressed by the last one, so you can start to keep those spots.
sure you leave me your phone before you go.